let's start with the first speaker, which is Stefano Fissolo. Stefano is an investment director at Susi Partner, which is a Zurich-based firm which is involved in financing energy transition and sustainable energy infrastructure. Before joining Susi Partner, Stefano was manager partner of Solesa, involved in renewable energy and energy efficiency projects in Italy and India, Oman, and Kenya. Before to start with Solesa, Stefano works as a project manager at Air Liquide Engineering and Construction in Paris, and also at Boston Consulting Group in Milan. Stefano has a degree in engineering physics in Turin and has two MBA in Paris and in Switzerland. Now, Stefano, the floor is yours. You can start with your speech.
Thank you very much for the kind introduction and for the invitation. Just to check whether you can hear me. I will then launch my few slides. So I have actually used the template of Susi Partners, but the slides are personal slides just made for the occasion, including some charts taken from different sources. And I try to diversify the sources in order to actually show different maybe point of views in the market. Let me start with a disclaimer. So, we work as an institutional player with pension funds, and we always like to start our presentation with disclaimers. Like in this case, the disclaimer is whatever I will show you is somehow data coming from before the Ukraine war, and it's unclear how the Ukraine war is actually going to change the situation on the short term and on the long term. My personal assumption is that the long-term situation will not change, while most probably on the short term there will be some deviation from what the market expected, the energy markets expected the situation to evolve until a few months ago. So clearly, COVID has been seen in the sector where I belong, as one pretty big occasion, opportunity to boost the energy transition, thanks to the recovery packages that have been approved mostly in the rich world, and this is currently at stake due to the Russian imports of gas and oil. But we hope this lose situation clearly for the violence and the crimes, and also lose in terms of emissions, is not going to last too long. Now, jumping into the matter, what we like to think as energy transition financiers is that to understand the sector, you just have to follow the money and see where the money is being spent, where the money goes. Before looking at where the money goes, let's look at what is the expected return of the different energy sources. And this is probably the best explanation for the tailwind that has been sustaining the energy transition since, I would say, the late 2010s, where you can see here, not only that clearly expected returns for fossil fuels are higher than for renewable energy, but also that while expected returns for fossil fuel are volatile, for renewable energy they are pretty much steady and declining, which means that in a demand and supply driven economy there is a huge demand for renewable energy and energy transition projects. So the actual reality on the ground is that there is a huge amount of capital chasing too few projects. And that's why the cost of capital is so depressed. And this will continue, we think, for the next foreseeable future. And with that tailwind in mind, let's see where the money is being spent. And you see here on the top that the money is primarily spent on renewable energy, so wind and solar. And starting with 2019 and going forward, also on the electrification of transport, so e-mobility and alike. That's where the majority of the money is spent, and that's where the majority of the energy transition will happen, just because that's where most of the money is spent. And then, since we're talking about venture capital today, at the bottom of the slide, you also see the venture capital component, which is what it's called climate tech corporate finance at the bottom, in the bottom chart. So basically, why on the left you have these energy transition investments, which are the investment made by structural players, players like Susie Partners, investing in projects and deployment of green technologies and green projects. In the middle, climate tech corporate finance, you have innovative companies that are raising money either through venture capital or growth equity or public markets. So IPOs, SPAC. We can observe the vast majority of the money is spent on actual deployment of projects, but we also expect the innovation part to pick up and increase significantly in the next years. In terms of breakdown, you see that, again, to the right, if you see the legend, it's always the renewable energy, electrification of transport, and also in the innovation part, it's energy and transport and mobility. The rest is not unimportant, but it's not where the majority of the money is spent or invested. And that leads me to the second principle. So first principle is follow the money to understand the energy transition. And the second principle is do not bet against the beast. What is the beast? The beast is basically solar and wind. So you can see here the annual capacity installation of new electricity generation assets from 2001 to 2020. In gray, the new capacity non-renewables in gigawatt, and in blue, the new capacity renewables. Renewables does not include nuclear. So you can see that basically the penetration of renewables in the new generating capacity has achieved 90%. 9 out of 10 gigawatts that are put in place greenfield in the world today are solar and wind. And then if we look at where does, looking at the future, the reduction of annual CO2 should come from, again, the chart is a bit complex. I wanted to put the IEA, the National Energy Agency, instead of Bloomberg, not to use always Bloomberg. The Bloomberg chart is similar, but a bit more sexy in terms of graphics, but I wanted to use another source. So now we have the IEA, which is not easily readable, but you can read the legend. The legend saying renewables and electrification made the largest contribution to emission reductions. Again, always the same story. The market expects, investors expects energy transition to be delivered through electric cars, solar, and wind. And then obviously there is other stuff, hydrogen, carbon capture and storage, biofuels, and this is all supposed to play whenever the beast, solar plus EV charging plus wind, do not have a role. So hard to abate sectors like, hard manufacturing or shipping or heavy transportation sectors where the simple combination of solar batteries and EV charging would not make the work. And we'll see later examples of those transactions. Still staying on the beast for a second, there is probably you all know this, but I wanted to touch base on technology, because venture capital is where finance meets technology. So it's good to talk about technology. Why renewable energy is basically the beast in the market? Because of the learning curves. So you can see here in the chart is that the predictions that have been made over time on the capacity additions and on the cost reductions for solar, wind, and batteries have significantly underperformed, meaning reality is always better than forecast. Or historically, the reality has always been better than the forecast. You can see, just as an example, solar PV here. In 2002, this was the expected evolution of the market. In 2010, this was the expected evolution of the market. In 2020, the market is actually evolving 36 times more, or at a higher pace compared to the initial predictions 20 years ago. Same for wind, same for batteries. Why? Because the learning curve of those sources is dramatic. The cost reduction per increase of market size is phenomenal. And it's similar to what has happened to the electronics industry. It's very easy to understand if we compare it to solar, because solar PV is made of silicon, which is the material of processors and basically semiconductors. So a similar story is happening to what has happened to electronics. In electronics, the cost of a megabyte, the cost of a transistor has constantly been reduced over time, thanks to R&D and thanks to the learning curve in production. Same is happening for renewables. I remember in 2010 when I joined the sector, I heard for the first time this, let's say, acronym, or not acronym, this principle, do not bet against the beast. In a conference in Munich, at Intersolar Munich, basically they were discussing whether in the future solar PV would be based on silicon wafers or on thin film. You may remember back then thin film was a very big thing. Venture capitalists invested into thin film technologies, and the expectation was that by today, half of the market would be actually using thin film solar photovoltaics. Well, guess what? Today, 95% of the total production of solar PV is based on silicon, and it's going to stay like that. So if I have to use the same, let's say the same example for batteries, everybody's talking about new technologies, but most probably lithium is going to stay with us for a long time. Now, the good news is that our life, meaning fighting climate change and the 1.5 to 2 degree scenario of the Paris Agreement, depends on existing technologies. This is pretty good. So we don't have to reinvent, let's say, or to bet on massive technological breakthroughs in order to solve the problem, tackle the issue. Well, the bad news is that we're not doing it enough. And that's the message that was given yesterday by the IPCC Council, by the Secretary General of the United Nations. I just copy-paste an article here. Now or never is basically what Antonio Guterres said yesterday, in order to put in place those technologies that exist today. Again, solar, wind, batteries, electrification of it with heat pumps and things like that. And the good news for investors like us is that the appetite for additional private money is bound to increase. So what you have on the right is a chart which actually has been compiled internally at SUSI, and you see where we expect the capital to be required in the next 30 years. Basically, a lot in energy efficiency, a lot in renewables, and a lot in electrification of heat and transport. With a gap compared to what has been planned today by the providers of this long-term capital, which means that there is still space for more players to come and join the party and help the world progress towards, the objective of limiting the temperature increase. If we look on the very short term, this is the 10-point plan of the IEA on reducing European Union reliance on Russian natural gas. And probably you cannot read it very well, but I try to highlight in red circles existing technologies technology incentives or measures compared to behavioral measures, or contractual measures. So the IEA is clearly mixing, no new gas supply contract with Russia, or behavioral changes like reducing the temperature in the apartments, with speeding up deployment of existing technologies. All it's based on existing technologies. And the 4 topics that I highlighted are maximizing generation from existing dispatchable low emission sources, bioenergy and nuclear. Second, accelerate the deployment of new wind and solar projects. Third, speed up the replacements of gas boilers with heat pumps, which is the electrification of heat, basically, and then accelerate energy efficiency improvements in buildings and industries. So long-term and short-term seem to actually hint to the same direction, which is do more of what exists today. Now, but I don't want to forget, that innovation still plays an important role, because technological innovation can basically provide the gap, this gap that we saw before, to actually really reach net zero and reach it in a short time. And so this is where venture capital money has been flowing last year. You cannot see much other than the fact that it's mostly energy and transport, as I said before, with a little bit of agriculture. And the way it has been invested is mostly proper venture capital, late stage and early stage. You can see it at the bottom part of the slide, with other alternative sources like crowdfunding picking up. Since the breakdown is not really relevant for our purposes, I looked at the venture capital number 1 in this sector, which is Breakthrough Energy Ventures. And this is probably, as you know, an initiative put together by Bill Gates with other American billionaires. And what Bill Gates did, first of all, was to change, because let's not forget that Bill Gates plays in the same space of others where the cost of capital is very low. Remember the first slide. So Bill Gates is a philanthropist, but he also wants to make money. So what he did, first of all, it changed the paradigm, and instead of showing the CO2 emission we are used to, as you can see on the right, where energy plays the big part, and that's why everybody focuses on energy, he has basically decided to look at the problem from an end-use perspective, rather a demand perspective of energy rather than a supply perspective. So the idea behind this venture capital is to give, let's say, dignity to things like agriculture with 19% of emission, and manufacturing with 31% of emission. Actually, according to his breakdown of the CO2 emissions, most of the emissions come from manufacturing and not from energy. Again, it's just a question of definition. The total is always the same, it's 51 gigatons of CO2 emitted per year. But by doing that, basically, it allows the venture capital firm that he basically has sponsored to look a bit beyond the traditional renewable energy. So what I did here, and this is the last chart, is just to map all the deals that this venture capital has done, 60 companies in which they have invested, on 2 axes. On the rows, you have these grand challenges that Bill Gates calls, and those are simply the CO2 emission components. So number 1, making things, manufacturing. Number 2, plugging in, electricity. Number 3, growing things, agriculture. Number 4, getting around, transportation. And number 5, keeping warm and cool, buildings. And on the columns, you have technology buckets. Not properly technologies, those are more themes, like electrification of heat, transport, renewable energy, energy storage. And where you see the most of the deals happening is clearly in IoT, AI, in terms of technology team. So this is a venture capital firm, and since it's a venture capital firm, it's scalability. And venture capital firms, they know IT and software pretty well, so it's not a surprise they invest a lot in software solutions. They also invest a lot on plugging in terms of CO2 components. And why is that? You see 21 deals made in the plugging in grand challenge. Why? Because it's the technology, as I was showing you at the beginning, where the most of the money is flowing and where people are comfortable, because there is track record, there is data, there is a clear evolution. People expect a a specific evolution of the market without big surprises. There is also an agricultural spot with 8 deals done in plant-based meat and biotechnology, and then energy storage, which with 8 deals, in particular lithium production. And with that, I think I can stop here, and I'm happy to take questions.